Have a delta math assignment if you haven't started that. Will be due this Sunday, yeah, the chapter 3 delta math.
Was there a delta math due yesterday?
No.
Just the worksheet.
The 2 worksheets, worksheet 2 and 3 was Sunday's assignment. So again, this should not be a super difficult delta math assignment. It's all things that we're doing, right? Like amplitude from a graph, midline from a graph, period from a graph, period from an equation, trig equation from a graph, write the trig function given features, all things that we've been practicing here for about a week and a half or so. So this should be something that's pretty familiar. And those are all, I think, relatively quick skills until you get to the very, very end there. And then I had assigned also 1 through 14 from the problems. Right, I saw some of us had started that already or completed it even already when I was checking homeworks, but not very many of you. So I just want to remind us that one was assigned last week. Sometimes those slip through the cracks where you have assigned on a Thursday of last week and do the following Sundays a lot of time. So just wanted to make mention of that. This week, we are going to finish chapter 3 today. Which makes Wednesday prospectively our review day, which makes Friday prospectively the test day. Okay, so if you're not going to be here, we'll just figure it out. We'll schedule makeup, right? Study hall or testing room, either is fine with me. Not a big deal.
You said this week, Friday?
This week, Friday. So just kind of looking ahead. I haven't gotten the new agenda for the week up yet, but I will here later this afternoon, hopefully. So what we're going to talk about today in 3.2 is the graph of the tangent function. So when I look at the parent function for tangent, we have the following attributes. So the first thing you notice that's a little weird is look at how the domain is written. So what it's saying is that every odd multiple of pi over 2, so for example, 1 pi over 2, 3 pi over 2, 5 pi over 2, or negative 1 pi over 2, negative 3 pi over 2, negative 5 pi over 2, this function is undefined. Also different than sine and cosine, the range for tangent is all real numbers as opposed to being bounded between negative 1 and positive 1. And the other major difference here is the period. Notice the fundamental period for tangent is pi rather than 2 pi. So if we do the same kind of discussion about the resultant function, I don't have that in here as separate things. I guess not. Okay. So let's look at the graph or graphing tangent. Well, let's say equation to graph. Let's use the same kind of vocabulary we've been using. So let's say we have y equals negative tan of x over 2. So just like any other graphing problem, I'm going to start by obtaining my values for A, C, H, and K by rewriting my original problem in that transformation form. So if I do that, I'd say I have negative 1 times tangent of 1/2 times x minus 0 plus 0. Is everybody okay with how I've taken my original equation there in black and written it in an equivalent version in red? So my A, C, H, and K are, negative 1, 2, 0, and 0. And just like before, I'm going to then write my transformation map, Cx plus H, comma, AY plus K. And then I'm going to go to my reference point sheet and look up the reference points for tangent, which is negative pi over 2 undefined, negative pi over 4, negative 1, 0, 0, pi over 4, 1, and then pi over 2 undefined. And I'm just going to write those in. So what does my new x-coordinate become for this first point? which reduces to just negative pi. Yep. And then what happens when I do negative of undefined? Well, it's a trick question, just still undefined. Doesn't matter what you do to undefined. You can't make it anything other than undefined. So what do I get for my new x coordinate for the next point? 2 times negative pi over 4 plus 0. What's twice a quarter? 2 quarters is a half. So that should be negative pi over 2. And then negative 1 times negative 1 plus 0 is 1. And then, well, 0, 0. 2 times 0 plus 0, still 0. Negative 1 times 0 plus 0, still 0. So what's 2 times pi over 4 for my next point? Positive pi over 2. And then negative of positive 1 is negative 1. And what's 2 times pi over 2? Positive pi. And negative of undefined is still undefined, right? Okay. So let's draw a picture here. Okay. So the first thing I'm going to do is graph negative pi comma undefined. How do I graph that though? Right? That's not a point because one of the coordinates is undefined. What do I do with that? That's going to represent an asymptote. Should it be a vertical asymptote or a horizontal asymptote? If I have an x comma undefined. Should be vertical because the x is telling us where to place it. So at negative pi, I have an asymptote. So when I draw that in, I draw it as a dashed line. Then I'll plot my point negative pi over 2 comma 1, 0, 0. Positive pi over 2 comma negative 1, and then we have pi undefined again. So I'll draw another asymptote, and I'm going to connect my points. I'm going to start up high following the asymptote, and then I'll curve to go through my points, and then I'll follow my asymptote again. But I'm going to go ahead and fill all the space that I'm provided. So I notice that I have 1, 2, 3 tick marks in between my asymptotes. So 1, 2, 3 tick marks. And then I should have another asymptote. And I have a point at a positive 1, at 0, and then negative 1. And I'll just follow my points. I'll do the same thing on the left side here. I have 1, 2, 3 points or tick marks in between my asymptotes. And I start with a point at 1, 0, and negative 1. And connect my dots. Everybody okay with how I drew that? Now, notice something about this graph. Does this have an amplitude? No, why not? There's no extrema because we have arrows going up and down to positive and negative infinity. So there's no amplitude on a graph like this. What is the period? What is the length of one full cycle here going to be? It's the distance from asymptote to asymptote, right? So we started over here at negative pi, and we ended here at positive pi. So how long is the length for our period? Going from negative 1 pi to positive 1 pi. That's 2 pi long, right? So what are we getting here? Well, the fundamental period for tangent is pi. So to get to 2 pi, we must have been pi times c. So unlike sine and cosine, one period for tangent is pi times the absolute value of c. That's different for sine and cosine. What would I do with that if I were you? I would put that on my note sheet because I know I'm going to forget that they're different. So I want to make sure I'd have that written down. Now, the midline, same idea. What would the midline be on this graph? Still looks like y equals 0, right? I'll just draw it this way. And that's still going to be y equals k. No worries there. Still the same thing. Nick? Why did I draw the graph 3 times? I just made some space. And then I said usually the instructions when I'm graphing are to fill the space provided. So I just drew an XY axis and then we filled what we had. I just wanted to draw more than one period so we can talk about how to fill out the space. Does that make sense? So was no real reason why I drew it 3 times as opposed to 1 time or 1.5 or 1, like I was just practicing for us to fill the space. Is that okay?
Yeah.
Yeah. So in general, when you're drawing a graph for tangent versus sine and cosine, is there much difference to the procedure? No, the procedure is identical, right? We're doing the exact same procedure. What's the only difference going to be? The shape of the tangent graph is just going to look different than the shape of the sine or cosine graph because it has those asymptotes in it. But other than that, it's the same thing, right? The same process. Everybody's okay with that? What if we want to go the other way from an equation back to its graph? Or I'm sorry, a graph back to its equation. What am I doing here, kids? I don't know. So again, if I want to write the equation here, I know my general form is going to be y equals a times tangent 1 over c x minus h plus k, right? So I need to figure out the values for a, c, h, and k. And once I've done that, I'm good, right? So the first thing that I'm going to do is figure out where the midline is. Yeah, it looks like it's right here, right? At -1. That's right. So what can I say about that? That k is -1, right? Okay. Now, the amplitude is usually how we come up with the a value, right? Everybody agree with that? Now, there is no amplitude for a tangent function, but what I can look at is that distance there, which is going to give me the absolute value of a. So how far is it from -1 to 0? From -1 to 0.
1.
That's 1 unit, right? So a should be plus or minus 1. So far, so good. I know that this is 1 period. So how far is it from -π/4 to +π/4? How far is it from -π/4 to 0? That's just π/4, right? And then from 0 to π/4 is another π/4, right? Everybody's okay with that? What's π/4 plus π/4? Well, 2/4 is a half, right? And I know that 1 period for tangent is found by what formula? Pi times the absolute value of c. So what does c in this case have to be? One half, right? Everybody's okay? And we always choose the c to be positive. Is this feeling familiar? It's like, hey, Mr. Kulik, this is like the same stuff we just do all the time. Yeah, man, it's like the same process. It's like literally the same thing. The shape is different, and the formula for the period is different. And like how we found the a value, like, well, it's not an amplitude we're looking for, but it's kind of still like the same thing, right? Now we're going to choose a point from our parent function. We're going to choose the point from our parent function 0, 0 because it has a 0 for the x-coordinate. That's a midline point. Before 0, 0, the graph points down. And after 0, 0, the graph points up. We're going to go to our resultant function. And we're going to pick a midline point. The one that I'm going to pick here is 0, 0. I'm sorry, 0, negative 1. That's a midline point where before the midline point the graph is pointing down, and after the midline point the graph is pointing up. So they're the same type of midline point, correct? What is that going to tell me? Just that my A has to be the positive option. And then because the x-coordinate from my parent function is 0, the x-coordinate from my resultant function should be h. And we're done. And if we want, we can clean that up a little bit, but that's fine the way we've written it. Let's do one more of these, right? This can be, sometimes these are the tricky ones, right? Drawing the graph is usually not so big of a problem. Let's do this again. All right. First things first, we find the midline. So that's here. So far, so good. Then we're going to look for the A value. So that's just going to be like the distance from that midline point to the next point, either to the left or to the right, it doesn't matter. If you notice, they're both going to be the same distance away. Right, if I went this way, that's still the same length. Everybody's okay with that? What is that distance there for A? We're going from 2 up to 5. How far is that? 3. So that tells me the A value should be plus or minus 3. Then we'll look for the period. So 1 period is just the distance between the two asymptotes. So our first asymptote is at negative pi, and our second asymptote's at 0. How far is it from negative pi to 0? 1 pi. And I know the period is pi times the absolute value of c. So what does c have to be? Just 1. And then the last thing we're going to do is from the parent function, we're going to choose the point 0, 0. We're always going to choose that point for tangent. On the parent function, the graph points down before that midline point, and it points up after the midline point. From my resultant function, I need to pick some midline point. The one I'm going to pick is the one that's labeled. I'm going to pick negative pi over 2, comma 2. And now before that point, which way is the graph pointing? It's pointing up, right? And after that midline point, the graph is pointing down. Is everybody good with how I just looked at the graph to see that? So if I compare the parent function to the resultant function, what can I say about the a value? It must be negative, because look at the way the graphs are pointing. They're opposite directions, right? So the parent function is down then up. My resultant function is up then down. And then if I look at the x coordinates, what should the h value be? Negative pi over 2. And that's all I need. And again, we could simplify that up to clean it up a little bit, but that answer is fine. What do you think? Feels the same still, right? Like the process still feels the same. Obviously, there's some details that are a little different, like how we find the a value is slightly different because there's no amplitude. The period formula is slightly different because it's 1 pi c as opposed to 2 pi c. But the procedure, like the overall procedure, the order that I do things, what I'm looking for, what I'm using, all very much the same process, right? Everybody feel okay doing this? I'm stopping then. If you guys say you feel okay. So at this point, let's see, last week we assigned number 1 through 14 and the delta math. This week I'm going to assign 15 to, I don't know, I think it's 20 something, 26 or something. Does that sound right? I have to go back and look. Okay, I'm just frustrated with you. I'm going to look somewhere else. It doesn't take a million years. Yes, 15 to 26. And I'm going to assign Chapter 3, Worksheet 4, but I'm only going to assign numbers 2, 6, and 8. And Chapter 3, Worksheet 5, but I'm only going to assign numbers, what are those numbers? 5 and 7. So you notice I went through and I X'd out the stuff that I don't want you to do on these worksheets if you're looking in the content library now. Right, I went and X'd out all the problems I didn't want you to do. Five and 7. And guess what we're going to do on Wednesday? The review. So I'm going to might as well write that down too. So a lot of things for this week, but the good news is you have the next like 30 minutes to start on some stuff. Tomorrow is all a work day, but what else should you be working on here in addition to these assignments?
Note card.
Your note card. Try to put your note card together, formulas before tomorrow or before next class, right? Try to get the formula part set on your note card. So all you're left to do is kind of write down some example problems. So as you're working on the review or as you're working on some of these homework assignments, you can write down some of those example problems, but really get the formula side set. If you don't have the formulas, yeah, of course, you're going to be in a lot of trouble because there's a lot of like just straight memorizing stuff like the things, the processes that we're doing are all kind of the same and they're not that difficult. But if you don't remember the formulas, don't remember like how to find the period or the amplitude or how to solve for C or whatever, like there's not a lot we can do. You know what I'm saying? This test is very much a, did you do a good job on your note card test? And if you did, everything usually goes really well for you. If you do like a half-butted note card, or you don't do one, you're usually in a lot of trouble because there's just a lot of stuff you'd have to memorize. Which again, if you're a math teacher who's been doing this for 15 years, no problemo. When you're a 17-year-old who's seeing it for the first time, big problemo, right? It's just a lot to ask. So do a good job on your note card, especially on the equation side, not just example problems. Really get down like all these little formulas. And if you want to put your formulas like inside of your example problem, so like for this kind of example problem, here are the formulas that I need to use. Like you can organize your sheet that way, but make sure you get the formulas on there. There's not a lot you can do without them, right? One way or the other. I leave it to you on how to organize it, but you need to do a good job with that. I'm going to stop talking now and let you guys get your grind on. Everybody happy? Okay. I know that's a lot of things to do this week, but we have a lot of time to do it too. So